Hello, and welcome to another lecture presented by www.free-academy.com. There's been a lot of interest in the past couple days of the limit as x approaches 0 of cosine of x minus 1 over x. Now I'm assuming that the students asking this question are actually asking for the limit as x approaches 0 of cosine of x minus 1 all divided by x, which is actually a much more interesting limit, and one that comes up a little bit more frequently, I'm sure. So I've decided to tackle this today. I don't have my tablet handy, so bear with my handwriting. The way we go about to doing this limit is actually using an approximation. This isn't directly solved. Notice that as you get really close to 0, so between -1 and 1 as being our bounds, say, your line y equals x looks like, it's a straight line. Everybody is aware of this at this point. But now also your sine of x, as it gets really close to 0, of course your sine x is a wave, goes like that. It's 0 at the origin. When you're really close to 0, sine of x and x look exactly the same. There's a straight line of, straight slope through the origin. So by knowing this and using this approximation, you can use the trig identity tangent of x over 2 equals cosine of x minus 1 over sine of x. As x gets really close to 0, this identity is exactly the same as saying tangent x over 2 equals the cosine of x minus 1 over x. Now if you get away from x equals 0, this does not hold, but around x equals 0, this is an accurate approximation. So by knowing this, you can take the limits as x approaches 0 of tangent of x over 2. Now recall that your graph of tangents looks approximately like this, with repeating asymptotes at pi over 2. So the limit of tangent of x as x approaches 2 equals 0. And that is your proof for the limit as x approaches 0 of cosine of x minus 1 divided by x. Hope this was helpful for you guys.